In this lesson, we want to review applications of linear equations and look at bill and coin problems. All right, so again, if we're solving application problems that involve a linear equation in one variable, we can use our little 6-step procedure. So again, for solving a word problem, we want to read the problem and determine the question or questions to be answered. Then we want to assign a variable to represent the unknown. We want to express other unknowns in terms of this variable. Then we want to write an equation, again, based on the situation given in our problem. Then we're going to solve the equation. Then we're going to write the answer in terms of the question or, again, questions asked. And lastly, we're going to check the answer using the words of the problem. We just want to make sure our answer is reasonable. So another very common problem type that occurs when we're solving applications of linear equations involves denominations of money. Okay, so these might be referred to as dollar word problems. You might hear them called coin word problems, just based on the situation given, okay? And essentially all you're doing here, you're normally given a value for all of the coins or all of the bills, and you need to find the individual amounts. So how many of, this type of coin do you have, or how much of this type of bill do you have, so on and so forth. So let's jump in and look at the first example. So we have Heather, a store clerk, has a total of $910 in her cash register. This amount comes from only 3 types of bills: $20 bills, $5 bills, and $1 bills. Now it says the clerk has double the amount of $20 bills as she has $5 bills, and half the number of $1 bills as she has $5 bills. Find the amount of each type of bill in her register. So this is a very, very straightforward problem. We just need to find, as it says here, the amount of each type of bill in her register. So how many $5 bills, how many $1 bills, and how many $20 bills. And again, this is based on the fact that there's a total value of $910 in the register. Okay, so let's let a variable be equal to one of our unknowns. Since the $5 bill is involved in both comparisons, let's let x be equal to that, right? Because it says the clerk has double the amount of $20 bills as she has $5 bills, and half the number of $1 bills as she has $5 bills. So let's let x be equal to the amount, or you could say the number of $5 bills in her register. All right, so what can we say about the number of $20 bills and the number of $1 bills? So if we go back up, it says here specifically, the clerk has double the amount of $20 bills as she has $5 bills. So if I take the number of $5 bills, which we modeled as x, and I double that, or if I multiply it by 2, that would give me 2x, and that would be the number of $20 bills that she's going to have. Let's put then, we'll put our 2x is equal to the number of $20 bills. Okay, so we go back up. For the number of $1 bills, it says half the number of $1 bills as she has $5 bills. So if I take half of x, or just 1/2 x, that's going to represent the number of $1 bills. So we'll say then, again, we're going to do 1/2 times x, or you can put x over 2, whatever you want to do, is equal to the number of $1, let me make that better, again, $1 bills. Okay, so how do we get an equation going? We've modeled all of our kind of unknowns, but we need an equation to get a solution. So let's go back up. Now it says a store clerk has a total of $910 in her cash register. Where the problem comes in, a lot of students at this point, they're used to kind of summing what they have and setting it equal to that value. So you see a lot of people do this. They'll go, okay, x plus 2x plus 1/2 x is equal to 910. This is not the correct equation. Why is that the case? Well, what I have on the left here is going to be the total amount of bills that she has, right? Between the $5 bills, the $20 bills, and the $1 bills. What I have on the right is a value, okay? So it's not the same. These two would not be equal. So suppose you had 6 $20 bills in your wallet or purse. How would you find the value there? You wouldn't say you just have 6 bills. You would say that you have 6 times 20, or $120, okay? It's, in other words, going to be found by multiplying the quantity of bills, which is 6, by the value of each bill, which is 20, which gives us 120, right? That's how we got the value. So we're going to basically do the same thing. To get our 910 total value, we need to take the number of $5 bills and multiply it by 5, plus the number of $20 bills, multiply it by 20, plus the number of $1 bills and multiply it by 1. So let's do this with a nice little table. Let's go down here. And essentially what I'm going to have here is the quantity of bills. And what I'm going to have here is the value per bill. And what I'm going to have here is the total value. Okay, pretty straightforward. So we have our $20 bills. Let's just label this as 20. And we have our $5 bills. We'll label that as 5. And we have our $1 bills. Just label that as 1. So the quantity of bills, again, if I go back up, I know that the $5 bills are labeled with X, the $20 bills are labeled with 2X, and the $1 bills are labeled with 1/2 X. So the quantity of bills, for the $5 bills, it's X. For the $20 bills, it's 2X. And for the $1 bills, it's 1/2 X. Or again, you can do X over 2. Now the value per bill, that's pretty easy. Just look all the way to the left. This one's going to be 20. This one's going to be 5. And this one's going to be 1. Okay, that's pretty straightforward. Then to get the total value, I just multiply across, right? This times this will be equal to this, okay? So 2X times 20 would be 40X. X times 5 would be 5X. And then 1/2 X times 1 would be 1/2 X. So now I have something that I can set up an equation with. I have the total value of the 20s, which is 40X, plus the total value of the 5s, which is 5X, plus the total value of the 1s, which is 1/2 X. And this is equal to, again, the 910, that amount of dollars, which is the total value in her cash register, okay? So you've got to go through and make this setup here. Otherwise, you're not going to get the right answer by just going through and saying, okay, I have 2X plus X plus 1/2 X and setting that to 910, because you're not setting a value equal to a value, okay? That doesn't work. So let's go ahead and solve this guy. I'm just going to copy this and go to a fresh sheet. All right, so what I can do, 40X plus 5X is 45X. Then plus 1/2 X equals 910. If I want to clear that denominator, let's multiply both sides of the equation by 2. So the 45X, if I multiply that by 2, I get 90X. Then plus 1/2 X times 2 would be just X. And this equals 910 times 2 would be 1820. And now 90X plus X would just be 91X. So let's write this as 91X. To get X by itself, I divide both sides of the equation by 91. And we're going to find that X is equal to 20. Okay? So again, we're not done. We have to go back and make sense of this. So X equals 20. So X was the number of $5 bills. So that's going to be 20. Then 2X is the number of $20 bills. 2 times 20 is 40. Then 1/2 X is going to be the number of $1 bills. So 1/2 times 20 is 10. Okay, so let's go back up and write our answer. So what we're going to say is that there are 20 $5 bills. And then you have 40 $20 bills. And you're going to have 10 $1 bills in her, let me make that better, register. All right, so let's check this and make sure it makes logical sense. So it tells us that, again, she has a total value of $910 in her cash register. So $25 bills is $100. Let me just line this up and put this as 100. 40 $20 bills is $800. And 10 $1 bills is $10. So sum those amounts. 100 plus 800 plus 10 is 910. So this part's a check. Okay, that works out. It says this amount comes from 3 types of bills: $20 bills, $5 bills, and $1 bills. Good to go there. The clerk has double the amount of $20 bills as she has $5 bills. Again, she has 25s and she has 40 20s. So we're good there. And then it says she has half the number of $1 bills as she has $5 bills. You've got, again, 25s and you've got 10 ones, so good to go there. So everything checks itself out. We can say our answer here is correct. We'll go ahead and just state this again. There are 25 bills, 40 $20 bills, and 10 $1 bills in her register. All right, let's take a look at another one. Again, these are pretty easy overall. So James, a local vendor, has a total of $5,600 in his carry bag. This amount comes from $20 and $100 bills only. If he has a total of 80 bills in his bag, how much of each type of bill does he have? So in other words, what we're trying to find here, it says how much of each bill does he have? We want to know how much of the $20 bills does he have and how much of the $100 bills does he have, because again, he only has those two types of bills in the bag. And again, another thing to highlight here is that he has a total of $5,600 and there's only 80 bills in the bag. Okay, so let's let a variable represent one of the unknowns. It could be the $20 bills or it could be the $100 bills. The key to understanding this problem is knowing that if he has a total of 80 bills in the bag, whatever I let X represent, then 80 minus X is going to represent the other one. So in other words, if I let X be equal to the number of $20 bills, then because, again, there's only 80 bills in the bag, it has to be true that we could say 80, the total number of bills, minus X, the number of $20 bills, has to be equal to the number of $100 bills. Okay? Let me make this a little bit better. Okay, so now that we have both of our unknowns kind of modeled, let's think about how we can get an equation going. So again, just like with the last problem, we're given a value, okay? But we've modeled things as kind of an amount of bills that we have. So we have to, again, go through, set up a little table, and relate the values. So let's go down here. And again, I'm going to say I have quantity of bills. I'm going to say value per bill. And I'm going to say total value. Again, if I take the quantity of bills times the value per bill, I will get the total value. So here I'm going to have my $20 bills, and here I'm going to have my $100 bills. So we said that the quantity of bills for 20s, we represented that with X. And the quantity of bills for hundreds, we represented that with 80 minus X. Now the value per bill for a 20 we know is 20. We know the value per bill for 100 is 100. And we just multiply across. So to get the total value for the $20 bills, it would be X times 20 or 20X. To get the total value for the $100 bills, it would be 100 times 80 minus X. So 100 times the quantity, remember you're multiplying by the whole thing, 80 minus X. Okay, so now we have the total value of the 20s and the total value of the hundreds, and we can sum those amounts and set it equal to the total amount that he has, which is $5,600. So in other words, I would have 20X plus 100 times the quantity 80 minus X. And again, this is set equal to the total value of his carry bag, which is $5,600. So let's copy this and go to a fresh sheet. So on the left, I have my 20X, and then plus, you've got 100 times 80, which is going to be 8,000. Then minus 100 times X is 100X, and this equals 5,600. So 20X minus 100X is negative 80X. And then again, you have plus 8,000. This equals 5,600. And now I'm going to subtract 8,000 away from each side of the equation. So I'm going to have negative 80x is equal to, if I have 5,600 minus 8,000, that's going to be negative 2,400. To get x by itself, I'm going to divide both sides of the equation by negative 80. So we know these cancel, and you're going to get that x is equal to 30. Okay, so let's take this result here, back up. Again, we said x was the number of $20 bills, so this is going to be 30. We said 80 minus x, or 80 minus 30, or 50, is the number of $100 bills. Okay, so we have our solution. Let's go back up. And now let's answer this guy. So we can say there are, again, 30 $20 bills and 50 $100 bills. To check this is very easy. You'd want to make sure the value works out. So 30 times 20 is 600. So the value from the 20s is 600. And then 50 times 100 is 5,000. Okay? So the value from the $100 bills is 5,000. 5,000 plus 600 is 5,600. So you're good to go there. Now the next thing you want to check is, does the amount of bills from the 20s plus the amount of bills from the hundreds give me 80 bills, which is what's in his bag. So there's 30 20s and 50 hundreds. 30 plus 50 is 80, so you're good to go there as well. So again, our answer is that there are 30 $20 bills and 50 $100 bills. All right, let's take a look at one more problem. And this is one that's going to be a little bit tedious. So we have Becky, a math teacher at a local elementary school, has a jar of mixed change in her classroom. The jar only contains pennies, nickels, dimes, and quarters, and has a total value of $89.50. She tells her class that the first person to correctly state the quantity of each type of coin present in the jar can take the jar home. Now, she states that there are 4 times as many quarters as pennies and 6 times as many dimes as pennies. Additionally, if the number of pennies was increased by 10, there would be 3 times more nickels than pennies. Find the quantity of each type of coin in the jar. So this one is tedious because you have 4 coins involved. You have pennies, nickels, dimes, and quarters. So that's the unknown here. Again, we're trying to find the quantity of each type of coin in the jar. So how many pennies, how many nickels, how many dimes, how many quarters. So let's start out by just modeling our unknowns. So let's let x be equal to the number of pennies. And we're going to do that because it's involved in all the comparisons. So it's just easier if you do that. So what can we say about the number of nickels, the number of quarters, and the number of dimes? So it tells us to start that there are 4 times as many quarters as pennies and 6 times as many dimes as pennies. So if there's 4 times as many quarters as pennies, that means we could say then 4x, or 4 times the number of pennies, which is x, is equal to the number of quarters. Then we can also say, again, since it told us that there are 6 times as many dimes as pennies, well, if there's x number of pennies, 6 times that amount would be 6x, so that's going to be my number of dimes. So 6x is equal to the number of dimes. Okay, so what can we say about the nickels? So what can we say about the nickels? So then it tells us if the number of pennies was increased by 10. So I have x number of pennies. If I increased it by 10, that would be x plus 10. There would be 3 times more nickels than pennies. So in other words, if I increase the number of pennies by 10, again, if I take x, the number of pennies, I add 10 to it. If I multiplied that amount by 3, that's how many nickels I would have. So again, if I multiplied 3 times the quantity x plus 10, this would be equal to the number of nickels. Okay, so now that we have everything modeled, again, we're told the total value of all the coins in our jar. At the start of the problem, that's going to be $89.50. So again, we got to think about the value of each coin. We're going to sum the values of all the coins, and that should be equal to $89.50. So let's use a little table. All right, so let's set this up in the normal way. So we have our quantity of coins. And then we have our value per coin. And then we have our total value. Okay, let me make that better. And again, if I multiply the quantity of coins by the value per coin, I'm going to get the total value for that set of coins. So again, I have pennies, which I'm just going to put a P for, or you could put 0.01. I have nickels, which I'm going to put an N, and I'll just put 0.05. I have dimes, which I'll put a D for, and then 0.1, or 0.10 if you want that. And then I have quarters, which I'll put a Q for, and this is 0.25. So quantity of coins. If we go back up, again, X is the number of pennies, 4X is the number of quarters, 6X is the number of dimes, and 3 times the quantity X plus 10 is the number of nickels. So for pennies, this was X. For nickels, this was 3 times the quantity X plus 10. For dimes, this was 6X. And for quarters, this was 4X. Now the value per coin is pretty simple. For pennies, it's 0.01. For nickels, it's 0.05. For dimes, it's 0.1, or you can put 0.10, whatever you want to do. And then for quarters, it's 0.25. So again, the total value I just multiply across. So for pennies, it's X times 0.01, or 0.01X. For nickels, it's 0.05 times 3, which is 0.15, then times the quantity X plus 10. Now you can simplify this here, or you can wait till later. Let's just simplify it here. 0.15 times X is 0.15X, and then 0.15 times 10 is 1.5. So let's put 0.15X plus 1.5. And then for dimes, it's 6X times 0.1. So that's 0.6X. And then for quarters, it's 4X times 0.25, which is 1X, or just X. Okay, so if we sum these total values for each, then what we're going to get is a value that is equal to $89.50. So in other words, if I take 0.01X, the value of all pennies, and if I add it to 0.15X plus 1.5, the value of all nickels, and I add it to 0.6X, the value of all dimes, and I add it to 1X, the value of all quarters, I'm just going to write X. This is equal to, again, the total value of the jar, which is $89.50. Okay, so let's copy this and go to a fresh sheet. So 0.01 plus 0.15 is 0.16. If I add 0.6 to that, I get 0.76. And then if I add another 1, again, this has an implied coefficient of 1, then I get 1.76. So the left side would be 1.76x. And then don't forget about this guy. So plus 1.5, this equals 89.50, or just 89.5 if you want. Now, if I subtract this 1.5 away from each side of the equation, this will cancel here. You have 1.76x is equal to 89.5 minus 1.5 is 88. Now to get x by itself, I'm going to divide both sides by 1.76. So we know that this is going to cancel, and you'll have that x is equal to 88 divided by 1.76 is 50. So this is our answer here, but again, we've got to go back and make sense of it. All right, so we know that x represents the number of pennies, and again, we found that x was 50, so there are 50 pennies. Then 4 times x is the number of quarters. Again, x is 50. 4 times 50 is 200, so there's going to be 200 quarters. Then 6x is the number of dimes. Again, x is 50. 6 times 50 is 300, so there's 300 dimes. And then lastly, 3 times the quantity x plus 10 is the number of nickels. So x again is 50. 50 plus 10 is 60. 60 times 3 is 180. So there's 180 nickels. So let's go ahead and write our answer. So find the quantity of each type of coin in the jar. We can say that there are 50 pennies, 180 nickels, 300 dimes, and then lastly, we'll say and there's 200 quarters. 200 quarters. We could say in her jar. Okay. So there are 50 pennies, 180 nickels, 300 dimes, and 200 quarters in her jar. So let's check this. So it tells us there are 4 times as many quarters as pennies. You've got 50 pennies and 200 quarters, so that checks out. So I'll just put a check there. Then we're told there's 6 times as many dimes as pennies. You've got 300 dimes and 50 pennies. So that checks out, right? 300 is 6 times 50. And then additionally, if the number of pennies was increased by 10, so if we went from 50 to 60, there would be 3 times more nickels than pennies. Well, yeah, if I had 60 pennies, I have 180 nickels. 60 times 3 is 180. So we're good to go there as well. Now, the last thing to check is the value. If I have 50 pennies, that's 0.5 or 50 cents. If I have 180 nickels, that's 180 times 0.05. It's basically $9. If I have 300 dimes, it's basically 300 times 0.1. That's going to be $30. And then if she has 200 quarters, that's 200 times 0.25, which is going to be 50. Okay? So 50 plus 30 is 80. 80 plus 9 is 89. Plus 50 cents is going to be $89.50. So we're good to go on our value, right? If we add everything up, we do get $89.50, which again is what it told us in the problem. So we can say our answer here is correct. There are 50 pennies, 180 nickels, 300 dimes, and 200 quarters in her jar.